everyone. In the today's session, we are going to discuss about the important questions and PYQs of the chapter Human Eye and the Colorful World. So, let's get started. First, let us solve some MCQs here. Let me read the first question. Which effect is seen during the sunrise and sunset due to the bending of light as it enters the Earth's atmosphere? We know that sun is visible to us about 2 minutes before the actual sunrise and also about 2 minutes after the actual sunset. It is because of atmospheric refraction. So, our answer will be early sunrise and delayed sunset. A and D will be our correct answer. So, see here among these both A and D. This is the correct answer. You can see here, this is our earth. A person is standing here. This is the horizon where the sky and earth appears to meet. What happens here? The sun is still not raised. But we are able to see the sun here. It is because the rays from the sun will reach into the observer eyes after undergoing atmospheric refraction. And it appears for this observer as if these rays are coming from this point. So that here this person is able to see the image of this sun. And for about 2 minutes he will observe this sun before the actual sunrise. It is due to the atmospheric refraction. And it is same with the sunset also. When the sun is set actually, what happens here? The rays from the sun will reach the observer eye after undergoing the refraction through the atmosphere. And these rays appears for this observer as if they are coming from here. And this sun is visible for him for about 2 minutes after the actual sunset. The next question is the colored light which refracts most while passing through a prism. We know that when white light is passed through a glass prism, what happens? This white light undergo refraction and also it is split into its constituent colors. That is called as dispersion. And what are those colors? They are violet, indigo, blue, green, yellow, orange and red. And we know that always the sequence of the colors that is obtained will be same. See here, when white light is passed through the prism, the white light will be split into 7 different colors. That is violet, indigo, blue, green, yellow, orange and red. Here the question is the colored light which refracts most while passing through a prism. You can see here the red light is bent the least and violet light is bent the most. Means this violet light is most refracted color. Hence our answer will be C, that is violet. Now a student sitting on the last bench is able to read the letters written in his textbook but cannot read the letters written on blackboard. Which of the following statements is correct? See here, this student is not able to read the letters written on blackboard, but he is able to read the letters written in his textbook, which means he is able to see the nearby objects clearly, but he is not able to see the far objects clearly, which means he is suffering from myopia, which means nearsightedness. That is, he is able to see the nearby objects. Nearsightedness means he is able to see near objects. Now, the question is which of the following statements is correct? The near point of his eyes has receded away. The near point of his eyes has come closer to him. The far point of his eyes has come closer to him. The far point of his eyes has receded away. Here you have to understand that he has no problem with the near point. The near point of his eyes is normal. That is 25 centimeter only. Because he is able to see the objects which is placed nearby. But only the problem is he is not able to see the far objects. Which means the far point of his eye has come closer. It is nearer than infinity. For a person who has normal eyes, his 4 point will be infinity. But here he is not able to see the 4 objects, which means that 4 point of his eyes has come closer to him. That is, option C is the right answer. Now, the next question is, the path of light rays passing through a glass prism is best described by which of these images? P, Q, R and S. In this picture, the white light is passed through the glass prism and it is split into 7 different colors, and red is on the top and violet is at the bottom. And in this picture, white light is passed through the glass prism and it is split into different colors, and white light is on the top and violet is at the bottom. In this case, the white light is passed through the prism, violet color is on the top and red color is at the bottom. And in this case, white light is passed through the prism. We are getting again the white color along with different other colors, and red color is also obtained, which is at the bottom. Now we have to choose the correct picture here. See here, in this case, white light is passed and red is obtained on the top and violet is obtained at the bottom. This is the correct path of the light rays shown. Whereas here, white light is incident. Again, they have shown the white here. It is not possible because white light undergo dispersion when it is passed through the glass prism. So, this will be wrong. Here also you can see white light is passed, whereas the sequence of colors which they have shown is not correct. Violet is shown on the top, but it is not correct. As we know that red color is having longer wavelength and it bends the least, and violet color bends the most. So it is wrong. You can see here again the white color is obtained. It is not possible. So this will also be the wrong answer. So our correct answer is P, only P. This is the correct answer. Which part of the eye converts incoming light signals into electrical impulses? We know that it is done by retina. Retina converts the incoming light signals into electrical impulses. On the retina, the real and inverted image is formed and it converts that light signals into electrical impulses. And optic nerves has the function that it will pass those electrical impulses to the brain. It will not convert those signals. Its duty is just to carry those electrical impulses to the brain. So the correct answer is retina. It will convert the incoming light signals into electrical impulses. Yes. Now, which of the following is not the characteristic of the image formed by human eye? Image size is smaller than object. Image is formed on the retina. Image formed is real and inverted. Erect image is formed on the retina. We know that the image that is formed on the retina is real and inverted. And that image size which is formed on the retina is smaller than object. Actually, that light signal is converted into electrical impulses by the retina and it is taken to the brain by optic nerves. And brain will help us to see the objects as they are. The one which is not the characteristic of the image formed by human eye is erect image, because erect image is not formed on the retina. Once that information is processed by the brain, we are able to see the different things around us as they are. Next, name the part of the eye that controls the amount of light entering into the eye and that has real and inverted image of the object formed on it. The answer for the first question is pupil will control the amount of light entering into the eye. So, this is the correct answer. And that part of the eye which has real and inverted image of the object formed on it, it is retina. Next, assertion A. The phenomenon of scattering of light by the colloidal particles give rise to Tyndall effect. The color of the scattered light depends on the size of the scattering particles. Yes, this assertion is true. The phenomenon of scattering of light by the colloidal particle will give rise to Tyndall effect. And reason is the color of the scattered light depends on the size of the scattering particles. Even though this statement is true, but this is not the correct explanation of the assertion. Both these are true. Both these statements are true, but this is not the correct explanation of A. The option B is correct, as the assertion and reason are correct, but the reason is not the correct explanation of A. Now, the next question is assertion A. A rainbow is a natural spectrum appearing and is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. The reason R is a rainbow is always found in the direction of sun. As we all know that rainbow, it is a natural spectrum. It is formed just after the rain shower and also when there is a sunlight at that time. It is formed due to the reason that the small water droplets of the rain, they will act as prism. There the dispersion is going to take place. And also by refraction, dispersion and internal reflection, the rainbow is formed. So this assertion A is correct, as a rainbow is a natural spectrum appearing and is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. This is true. Now reason R. A rainbow is always found in a direction of sun. It is not true, because we know that this rainbow is formed in the direction opposite to the sun. So assertion A is true and reason R is false. Our correct answer is A is true and R is false. Next, state the role of ciliary muscles in accommodation of eye. We know that ciliary muscles has the function that it can change the curvature of the eye lens, so that focal length of the eye lens can be adjusted, because of which we are able to see the nearby and far objects clearly. So ciliary muscles have the capacity to change the curvature of eye lens, so that the focal length of eye lens can be adjusted according to the requirement. These ciliary muscles are flexible, they can stretch and also they can contract, because of which they are able to change the curvature of the eye lens. So the focal length of the eye lens can be changed, because of which we are able to see the nearby and far objects clearly. Next, why do components colors of incident white light split into a spectrum while passing through a glass prism? We know that when white light is passed through a glass prism, there the dispersion is taking place. The white light is splitting into 7 constituent colors. It is happening due to the reason that different colors are bending through different angles with respect to the incident light. So these rays of different colors, they will follow the different paths, because of which these colors will be seen distinctly. Yes. So when white light is passed into a glass prism, it splits into 7 constituent colors, because bend through different angles with respect to the incident light. So the rays of each color follows different path, and we know that different colors have different wavelengths. Red color has longer wavelength, it bends the least, and violet color has shortest wavelength. Among all the colors, it will bend the most. In this way, we will get the different colors when white light is passed through a glass prism. Now, next question is, a person needs a lens of power plus 3 diopter for correcting his near vision and minus 3 diopter for correcting distant vision. Calculate the focal length of the lenses required to correct these defects, which means here the person is suffering from both near vision defect and also distant vision defect. We have to calculate here the focal length. First, let us calculate the focal length for lens of power plus 3 diopter. Let's take it as f1. We know that focal length is given by the formula f is equal to 1 by p. So 1 by p1. It is equal to 1 by plus 3 meter. So F1 is equal to 0.33 meter. Let's calculate here F2. Here the person is suffering from distant vision defect. So minus 3 diopter is the power. Minus 0.33 meter. Because of which the person should be given a bifocal lens which consists of both the concave and convex lens. This shows that for near vision defect, convex lens is used, and for distant vision defect, this concave lens is used. Next, the question is, a person is advised to wear spectacles with concave lenses. What type of a defect of vision is he suffering from? We know that concave lenses are used when a person is suffering from myopia defect. In that case, the person is not able to see the far objects, but he is able to see the nearby objects. So, the answer is myopia. Concave lenses are used when the person is suffering from myopia. What happens in myopia? You can see here. For a person suffering from myopia, the far point of his eye is nearer than infinity. For a normal eye, we know that the far point of the normal eye is infinity. It is just few meters away from him, away from his eyes. So let's see here, this is the far point of the myopic eye. Beyond this, the person is not able to see the objects clearly. Up to this point, he is able to see the objects clearly. But after this point, he is not able to see the objects clearly. So what happens here if the object is kept here beyond the far point of his eye? Then the rays coming from it are parallel as it is placed at a very larger distance. These rays are converged before the retina and the image is formed in front of the retina. Instead of forming on the retina, the image is formed here. Why does this happen? It is happening due to the increase in the curvature of this lens and also elongation of the eyeball. Because of that, the converging power of this eyes will increases and the image is formed here only. That is, it is formed in front of the retina. So, he is not able to see the distant objects clearly. How do we correct them then? We are able to correcting this defect by using concave lens here. What does the concave lens will do? It will diverge the rays by some amount so that these rays are not diverged here only. They should be, what does the concave lens will do? It will diverge the rays by some amount so that these rays are not converged at this point. We want to converge these rays and form the image here. We do not want the rays to be converged here only. So we are using here the concave lens so that by some amount these rays are diverged and the image is formed on the retina. Now the next question is define the term angle of deviation. Define the term power of accommodation and write the modification in the curvature of the eye lens which enables us to see the nearby objects. Let's answer the first question here. We know that angle of deviation is the angle between the direction of incident ray and the emergent ray. See here, this is a prism. When a ray of light is incident here, it gets refracted as it is moving from rarer medium to denser medium. It will be refracted towards the normal. Again here entering from denser medium to rarer medium. So it will be refracted away from the normal. It is a normal and this is the normal at this point. Now you can see here, this is the direction of the incident ray and this is the emergent ray which emerges out of the prism. If you extend this, we get the angle between the direction of incident ray and the emergent ray. This angle is called as angle of deviation. So the angle between the direction of incident ray and the emergent ray is called angle of deviation. Now, next question. Define the term power of accommodation. Write the modification in the curvature of the eye lens which enables us to see the nearby objects. We know that power of accommodation is the capacity of eye lens to change its focal length, because of which we are able to see the nearby and far objects clearly. It is the capacity of eye lens to change its focal length. It is called as power of accommodation. And we have to write here what modification does the eye lens do. And we have to write here the modification in the curvature of eye lens which enables us to see the nearby objects. Suppose if we are seeing here the nearby objects, what happens here? The ciliary muscles will contract. The ciliary muscles contract, because of which the curvature of the eye lens will increases. It causes increase in the curvature of eye lens. So eye lens will become thicker. Becomes thicker. Because of which the focal length of the eye lens will be decreased. The focal length of eye lens is decreased. So we are able to see the nearby objects clearly. This is the modification which is done by ciliary muscles in order to see the nearby objects. Now, next question is, a person having myopic eye use the concave lens of focal length 50 cm. What is the power of the lens? As concave lens is used, we have to take the focal length in the negative sign. So, focal length of the lens is 50 cm. That is, we have to take here negative sign as it is concave lens. It will be 1 upon, when it is converted into meters, it will be 0.5 meter. Now we have to calculate the power of the lens. P is given by 1 upon F, which is equal to 1 upon minus 0.5. It will be equal to minus 2 diopters. So power of the lens is minus 2 diopters. Next, the question is, a person needs a lens of power minus 4 diopter for correction of her vision. The questions are, what kind of defects in vision is she suffering from? What is the focal length of the corrective lens and what is the nature of the corrective lens? See here, the power of the lens is minus 4 diopter. The negative sign indicates that the focal length of the lens is negative. For which lens the focal length is negative? Yes, for concave lens the focal length is negative. So this shows that the lens which is used for correction is concave lens. When do we use the concave lens for correction? When the person is suffering from myopia. We are going to use concave lens. So what kind of defect in vision is she suffering from? She is suffering from myopia. Next, what is the focal length of the corrective lens? We know that focal length is given by the formula F is equal to 1 upon P. F is equal to 1 upon P, which is equal to 1 by minus 4 meter or 25 centimeter. So F is equal to 25 centimeter. The focal length of the length is minus 25 centimeter. Next, what is the nature of the corrective lens? We know that concave lens is used here. So what is the nature of concave lens? It is diverging in nature. Next, draw a neat diagram to show refraction of light light ray through a triangular glass prism. Mark the angle of incidence, angle of emergence, incident ray, refracted ray, emergent ray, and the angle of deviation. This is a prism. This is the incident ray. When it falls on the prism, it gets refracted along this way. This is the normal at this interface. And again it gets refracted as it is entering from denser medium to rarer medium. And this is normal at this point. We know that when the ray enters from rarer to denser medium, it will get refracted towards the normal. And when it enters from denser medium to rarer medium, it will refract away from the normal. This is the angle of refraction. And this is the angle of incidence. This is the angle of emergence. And in the absence of the prism, the light would have travelled this way. If you extend this, we will get the angle of deviation. This is angle of deviation. The angle between the two lateral surfaces is angle of prism. Now we can mark the angle of incidence, angle of emergence, incident ray, refracted ray, emergent ray, and the angle of deviation. Let's write it separately here. PQ, it is incident ray. You have to show it by arrow which light is incident here. Then it get refracted along this way. QR is refracted ray and RS is emergent ray. And also we have to mark the angle of deviation here. Yes. D is the angle of deviation. This I is angle of incidence. And this E is angle of emergence. The angle made by the emergent ray with the normal. Now we have marked the angle of incidence, angle of emergence, incident ray, refracted ray, emergent ray, and angle of deviation. This is how we have to show the diagram for refraction of light ray through a triangular glass prism. Now the question is, observe the following diagram and answer the following questions. This is the diagram which is given. We have to answer these questions. Identify the defect of vision shown. You can see here the image is formed in front of the retina. So the person is suffering from the defect myopia. What is the condition of eye in myopia? The person is able to see the nearby objects, whereas he is not able to see the far objects. The far point of an eye is nearer than the infinity in case of myopia. Here, far point of the eye is nearer than infinity. So what happens here? These rays which are coming from the object which is kept far away than the far point of the myopic eye, they are converged in front of the retina, because of which the image is formed in front of the retina instead of forming at retina. So he is not able to see the objects clearly which are placed far away. Hence, the defect of vision here is myopia. Why this myopia causes? It is caused due to the excessive curvature of the lens and also elongation of the eyeball, because of which the converging power increases and these rays are converged at this point only. Now, what are the causes of this myopia? It is caused due to the increase in curvature of eye lens and also elongation of eyeball. Now, what happens to a beam of white light when it gets refracted through a glass prism? Which color deviates the most and the least of the refraction through a glass prism? What is likely to happen if a second identical prism is placed in an inverted position with respect to the first prism? Justify your answer. When white light is passed through a glass prism, here the dispersion of the white light takes place to form 7 different constituent colors, as white light is made up of 7 different colors. You can see here red light bends the least and violet light bends the most. You can also say the red light is deviated by small angle and the violet light is deviated through large angle. And again what happens here, when the spectrum of light which is obtained here, you have got here 7 different colors. For convenience I have shown you 2 colors here, but totally there are 7 colors which are obtained. When the spectrum of these colors which are obtained is again passed through another prism which is kept in the inverted position, here the recombination of the colors takes place again to form the white light. Here they have asked the question that what happens to a beam of white light when it gets refracted through a glass prism? You have to write here dispersion of white light takes place when it is passed through glass prism to form 7 constituent colors. What are the colors which we obtained here? With gear: violet, indigo, blue, yellow, orange, blue, green, yellow, orange and red. You can remember it as with gear. Yes, again they have asked which color deviates the most. See here, the violet color has deviated the most. So write here violet color deviates the most. Red color deviates the least. Then what is likely to happen if a second identical prism is placed in an inverted position with respect to the first prism? Here we have placed an inverted prism and after we have got the spectrum of colors, we are passing these colors into the second prism. Now the recombination of these colors takes place to form again white light, because this prism is placed now in the inverted position. So recombination of colors takes place when identical prism is placed in inverted position. Yes. Name the component of white light that has the greatest wavelength. Next the question. Light of two colors A and B pass through a glass prism. A deviates more than B from its path of incidence. Which color has a higher speed in the medium? First write the answer of first question. Now let's write the answer of this question. Name the component of white light that has the greatest wavelength. Red color has greatest wavelength. And the second question is, light of two colors A and B pass through a glass prism. A deviates more than B from its path of incidence. Which color has higher speed in the medium? See here, color A deviates more, which means the speed of color A is less in that medium, which shows that speed of color A is less and color B deviates less. So the speed of color B is more the deviation, less is the speed, and less the deviation, more is the speed of the light ray. Now explain with the help of diagram why the sun is visible to us 2 minutes before the actual sunrise and 2 minutes after the sunset. We know that sun is visible to us for about 2 minutes before the actual sunrise and also for about 2 minutes after the actual sunset. It happens due to the atmospheric refraction. What happens here is, this is our earth. The sunrise has not taken place yet. The rays coming from the sun, after reaching the earth atmosphere, it gets refracted by the layers of atmosphere, and those refracted rays will reach the observer's eye. And it appears for an observer that these rays are coming from this point. The refracted rays are reaching the person's eye, and it appears for this person that these rays are coming from here, because of which this person is able to see the sun for about 2 minutes even before the actual sunrise. And the same thing happens with the sunset also. When the sun is set here, the rays are coming from the sun and reach the observer's eye after getting refracted through the atmospheric layers. That is, atmospheric refraction has taken place, and it appears for an observer's eye that these rays are coming from this point. Because of that, he will see the sun for about 2 minutes even after the actual sunset. The rays of light from the sun below the horizon reach our eyes because of refraction of light through atmosphere. These rays appear to come from the apparent position of the sun, which is above the horizon. This is called as apparent position. Actually, the sun is not here. Therefore, it is called as apparent position. The rays are coming from the sun, and those rays will undergo refraction and reach the observer eye. And it appears for this observer that these rays are coming from here, and the image is formed in this position. That is called as apparent position of the sun. Now, what is a rainbow? Draw a neat label diagram to show the formation of rainbow. We know that rainbow is a natural spectrum which is obtained after the rain shower and also when there is sunlight. Why does this happen? It is due to the mainly three phenomena involved here: refraction, dispersion and internal reflection. Let's see how rainbow formation takes place here. It is mainly due to the three phenomena involved: refraction, dispersion, internal reflection. What happens here? When the sun rays are coming from the sun and they fall on the raindrops, these raindrops will behave as prisms, and that sunlight will undergo dispersion. Once it gets refracted here, it will undergo dispersion to produce different colors. And again, some part of these rays are get refracted also. Some of the rays whose angle of incidence is beyond the critical angle, the internal reflection takes place like this. And these colors undergo refraction again and reach the observer's eye, because of which we are able to see the different colors in the form of rainbow. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. You have to draw this diagram for this question. Now, the question is, how are we able to see nearby and also distant objects clearly? It is mainly due to the reason that the eye lens focal length can be changed. Suppose if we want to see the nearby objects, what happens? The ciliary muscles will contract, which causes the increase in the curvature of the eye lens. The eye lens become thicker, because of which the focal length is decreased and we are able to see the nearby objects. And what happens when the objects are far away? In that case, the ciliary muscles are relaxed, because of which the curvature of the eye lens will be decreased and the eye lens will become thin, because of which the focal length will increase and we are able to see the far away objects. The eye lens is composed of fibrous jelly-like material. It is flexible in nature. The eye lens curvature can be changed by the ciliary muscles. Means its curvature can be modified by ciliary muscles. Its curvature can be modified to some extent by the ciliary muscles. The change in the curvature of the eye lens can change its focal length. What happens here? When the muscles are relaxed, the lens becomes thin. Thus, its focal length increases. This enables us to see the distant objects clearly. And when you are looking at objects closer to the eye, the ciliary muscles contract, which causes the increase in the curvature of the eye lens. The eye lens then become thicker. Consequently, the focal length of the eye lens decreases. This enables us to see nearby objects clearly. As we know, this ability of the eye lens to adjust its focal length is called as power of accommodation. Yes? Now, what is atmospheric refraction? List two natural phenomenon based on atmospheric refraction. We know that our Earth's atmosphere is made up of different layers, and these different layers have different densities, because of which the rays which are coming from the sun, they undergo refraction continuously as they passes through the different layers. This phenomenon is called as atmospheric refraction. So it is the refraction of light by the Earth's atmospheric layers having varying refractive indices. And the two natural phenomena based on atmospheric refraction are twinkling of star and advanced sunrise and delayed sunset. Now, the last question is write the functions of each of the following parts of the human eye: cornea, iris, crystalline lens, ciliary muscles, retina. Cornea is the outermost covering of the eye and it allows the light rays to enter into our eyes. Iris, it is the dark muscular diaphragm which you are going to see in the eyes. The colored part of the eyes which you are going to see is called as iris and it maintains the size of the pupil. Crystalline lens is the fibrous jelly material and it is the convex lens that is present in our eyes. It forms the real and inverted image in our eyes on the retina. Ciliary muscles, these are the muscles which helps in changing the curvature of the eye lens by relaxing and contracting. And retina, it is the screen present in our eyes where the real and inverted image is formed, and also it converts the light signals into electrical impulses which are carried by optic nerves to the brain. So cornea, it is a thin membrane on the front surface through which the light enters the eyes. Iris is a muscular diaphragm that controls the size of the pupil. Crystalline eye lens, it is a flexible convex lens which provides the real eye inverted image on the retina. Ciliary muscles, as we know, they are helpful in changing the curvature of the eye lens so that we are able to see the nearby as well as distant objects clearly. Retina, it is a delicate membrane having enormous number of light sensitive cells called as rods and cones. These rod cells are sensitive to the intensity of light. We are able to see even in dim light because of these rod cells, and these cone cells are responsible for seeing different colors. This is all about the important questions and PYQs of the chapter Human Eye and the Colorful World.